Now let's look at exponential graphs and exponential tables. First of all, I want you to notice the first example that I gave you, which was y equals 3 times 2 to the x, all right, where 3 is my a value and 2 is my b value. So to recap from yesterday's lesson, 3 is going to be my y-intercept. That's why you see that, all right? And the 2 is basically saying that my function is going to grow by 100% because 2 minus 1 is 1, or 100%, all right? Also, you can tell that it is going to be doubling your output every time. So for example, at 0, your output is 3. At 1, your output is 6. And at 2, your output is 12. All right, so you're doubling. All right, now another thing to know about the exponential function is the graph goes all the way to the left, all the way to the right, meaning that the domain is all real numbers. Again, the a value is your y-intercept, and the b basically determines if you're going to have exponential growth or exponential decay. So exponential growth, for example, is going to happen when, again, when your b value is larger than 1, right? And exponential decay is going to happen when you have a decimal b value or a fraction b value that is between 0 and 1. Okay, now to some quantitative items. Tables. Tables are extremely important. So I've made a table with y equals 3 times 2 to the x. And let's take a look at the pattern. So again, I'm going to look at x values going up by 1, 0, 1, 2, 3, 4. Look at my y values. All right, you can predict the y value of 3 is your y-intercept because it's right there in the equation. All right, but look at the pattern. You go from 3 to 6, and then from 6 to 12, then from 12 to 24, and from 24 to 48. So basically what's happening with your values is that you're doubling. So you could expect, for example, 5 to be 96, and it is. Okay, so you are basically doubling those values. That's what that b value determines, that you multiply by b amount. All right, that is exactly what is happening right there. All right, so this is times 2, right? Times 2. Whereas if we had a linear pattern, you might see something like, okay, output of 3, output of 6, and then an output of 9, because what happens in linear patterns is you really have a common difference. You're adding each time. You might say, okay, well, let me add 3 each time. So that's the biggest difference really between linear and exponential. So that is really the bulk of the lesson right there, that we need to understand the a value is my value at 0, and the b value is basically talking about my growth or decay factor. Okay. And as long as you know your y-intercept and maybe one other point, you are absolutely fine. All right, so one last example right here. What if I'm given some clues about a function? So I'm told, okay, the y-intercept of this function is going to be 0, 8, but then there's another point, 4, 648. So we want to think about our equation. Well, we know that it's going to be y equals a times b to the x. And what we know about this is, well, we know that the value of a is going to be 8. So we know this is y equals 8 times some b value raised to the x power. All right. So if you want to actually figure out what the b value is without really just guessing and checking, because if we guessed and checked, we'd have to, I guess, make a table of x and y, right? We'd have lonely little 0, 8. We don't know what the output is at 1. We don't know the output at 2. We don't know the output at 3. We know the output at 4 is suddenly 648. So you'd want to think, well, what's happening in between? What am I multiplying by to grow so large? All right. So what you're going to want to do with this is, well, think of this as an XY coordinate. And what you're going to do is really just, evaluate into this function, substituting for X and for Y. So I can say 8 times B to the, and my X value is 4, X times B to the 4th is going to be equal to 648. All right. Then I divide 648 by 8. So I get, what is 648 divided by 8? And so I divide 648 by 8 and I get 81. So 81 is b to the 4th. To solve for b, I can take the 4th root from both sides. And it so happens that the 4th root of 81 is 3, because 3 to the 4th is 81. In other words, the real pattern right here is that you're tripling. So b equals 3, and you have your final equation of y equals 8 times, and that's horrible, 3 to the x.